$34,200 bought the panel package for this building. That is the shell walls and roof, delivered cut to the drawing. Now hold that number against something ordinary. The median major kitchen remodel in 2026 runs $81,240. One room, cabinets, counters, appliances, flooring, and the labor to install them. The shell of an entire house costs less than half of one kitchen. Let me correct the obvious thing before it does damage. Shell means shell. No slab, no wiring, no interior, no labor. The finished number is several times this, and I will give you every line of it. But the panels themselves buy something a $300,000 house does not have, and I will show you the measurement. There is also one number that decides whether a building like this lasts 30 years. It never appears on the invoice. A town in Alaska found that out in 2001. Start with the product, because it is unlike anything else that arrives on a building site. A structural insulated panel is a sandwich. Two facings of oriented strand board bonded to a rigid foam core, usually expanded polystyrene. That is the whole thing. No studs inside it, no cavity, no framing members anywhere. And it does 4 jobs at once: structure, sheathing, insulation, air barrier. On a conventional site, those are 4 separate operations run by 4 separate crews, and here they arrive on a truck already combined into a single product. Core thickness sets your R value, and the relationship is straightforward: roughly 6 inches of polystyrene to reach R20, which is why these panels are not small. One of them weighs between 90 and 100 pounds. They show up cut. Window openings, door openings, electrical chases, all machined at the factory from your drawings, numbered and stacked in the sequence they go up in. Now the pricing, and this is where people get confused quickly. SIPs run $17 to $30 per square foot, material only, depending on core thickness, facing material, and how complicated your cuts are. $34,200 at that rate buys the panel package for a compact Barndominium. Call it 800 to 1,200 square feet of finished floor, depending which end of that price band you land on. If that strikes you as a small building for the money, hold on to the feeling, because there is a specific reason for it, and it is the most useful thing in this video. You are not buying the number you think you are buying. Here is the unit problem, and it catches almost everyone. You are not buying floor area. You are buying envelope area, every square foot of wall and roof it takes to wrap the building. Those two numbers are not close to each other, and nobody explains the difference before you call a supplier. Run it on a real footprint. Take a 24 by 32, that is 768 square feet of floor, which sounds modest. Now measure what it takes to enclose it. The perimeter is 112 linear feet. At 10 feet tall, that is 1,120 square feet of wall panel. Add the roof, which depending on your pitch runs somewhere around 900 square feet. So you are buying roughly 2,000 square feet of panel to enclose 768 square feet of living space. At $17 a square foot, that is about $34,000. There is the number, and now it makes sense. You are paying for nearly 3 square feet of product for every square foot of floor you get to stand on. Openings come out of that, which helps a little, though the machining is part of what you are paying for regardless. And one consequence worth carrying into your design. The ratio gets worse every time you add a corner. A simple rectangle wraps efficiently. An L shape, a bump out, a dormer, or a complicated roofline all add envelope without adding floor, and you pay for every square foot of it. With panels, simple shapes are not a compromise. They are a discount. So how does that number compare to what people spend on ordinary things? Angie's 2026 data puts the average American kitchen remodel at $26,962, with most projects landing between $14,500 and $41,500. Read that range again and notice where $34,200 sits. Right in the middle of it. The panel package for an entire building costs what an ordinary kitchen renovation costs, not a lavish one, an average one. Step up a tier, and the gap opens properly. The cost versus value benchmark puts a major mid-range kitchen remodel at a median of $81,240 in 2026 semi-custom cabinets, an island, countertops, a full appliance suite, flooring, and lighting. That is the tier most people actually picture when they say the word remodel. The shell comes in at 42% of that figure. One room, priced at nearly 2.5 times the structure, sheathing, insulation, and air barrier of a whole house. Go up once more. An upscale kitchen runs a median of $159,880. The shell is roughly a fifth. Now here is the part that sharpens the comparison, and I think it is the honest version of it. That major mid-range kitchen recoups about 58% of its cost at resale. The upscale one returns closer to 48%. So something near half the money you put into a kitchen simply does not come back to you. An envelope behaves differently. It is not waiting for a buyer to agree with your taste. It pays you every month in a smaller bill for as long as the building stands. But before any of that comparison means anything, I owe you the rest of the number. $34,200 is walls and roof, sitting on the ground on a truck. It does not include the slab you set it on. It does not include the crane, and you will need one, because roof panels on even a single-story building are not going up a ladder. It does not include the crew that erects it, and it does not include a single thing that happens after the building is weather-tight. No interior partitions, which are framed conventionally in a panel house exactly like any other. No plumbing, no electrical, no heating and cooling equipment, no drywall, no flooring, no cabinets, no fixtures. The industry has a rule of thumb for this, and it is worth memorizing. A weather-tight shell is roughly 20 to 40% of your finished cost. The interior is the majority of the budget, and it is where nearly all the variation between two identical buildings comes from. So what does the finished number actually look like? Owner-directed, at a standard finish, Barndominiums land around $80 to $120 per square foot. Hand the whole project to somebody else, and turnkey SIP homes average $150 to $220 per square foot, which the industry itself describes as comparable to premium custom builds. That is a real range, and I am not going to soften it. Anybody presenting a shell price as a house price is either confused or selling you something. Which brings me to the most useful sentence in this entire video. It works on every supplier, every builder, and every quote you will ever receive for any building system. When somebody hands you a number, ask exactly one question. What is not included in this number? The answer sorts honest quotes from optimistic ones in about 4 seconds. And it is precisely why people budget for a $34,000 shell and find themselves badly short 8 months later. Now, what that shell actually buys you in return. There is a test that tells you more about a house than any other number, and hardly anyone buying one ever asks for it. Seal a fan into a doorway, depressurize the building to 50 pascals, and measure how much air leaks back in. The result is air changes per hour at 50 pascals, and it is the closest thing construction has to an honest report card on an envelope. A code-built house typically lands between 3 and 7. Now, the physical property that makes panels different, Both the oriented strand board and the polystyrene are air-impermeable materials. Air does not pass through either one, which means across the entire field of a panel, the whole surface between one joint and the next, there is no leakage at all. Not slowed. None. There is nothing for air to travel through. A panel building leaks only at its joints. Everywhere else, the envelope is simple. The documented results follow. Panel houses commonly test under 1 to 1.5. One builder measured 1.7 on his own house. Another came in at 0.6, which is passive house territory. Set those against 3 to 7, and you have an envelope 3 to 10 times tighter than the code-built house down the road. Then thermal bridging, which matters especially if you are comparing this against a steel Barndominium. Every framing member running from inside to outside carries heat around your insulation. In wood, that path is mediocre. In steel, it is excellent, and the Barndominium industry says so directly. Thermal bridging through steel framing is a genuine performance problem, and batt insulation between framing underperforms badly in those buildings. A panel has no framing members. The insulation runs continuous, corner to corner. Put those together, and SIP buildings typically cut heating and cooling costs 40 to 60%, with payback in 3 to 7 years. And it goes up fast. Construction time drops by as much as 55%. An 8,000 square foot house in rural Oklahoma was framed and fully enclosed in 13 days. Two costs ride along behind that panel price, and neither one is optional. The first is equipment. Roof panels need a crane, even on a single-story building, because a 90-pound panel that runs 20 feet long is not going up on shoulders. Budget for the machine, and budget for the day it sits in your yard doing nothing because something else was not ready when it arrived. The second is people. Panel erection takes contractors who have done it before, and the ceiling work in particular is where inexperience hides. A crew learning on your building will produce something that looks finished and performs like something else, and you will not find out for years. Then there is a third cost that is not money at all. It is flexibility. Panels are machined from your drawings before anything ships. Every opening, every chase, every dimension is fabricated in advance. So moving a window after the order is placed is not a framing change, it is a manufacturing change, and it is priced like one. With stick framing, you can decide some things standing on the site with a tape measure. With panels, you decide them at the drawing stage, and then you live with them. That trade is genuinely fine if you are a planner. It is miserable if you are not, and knowing which one you are is worth more than any number in this video. Now, the one that decides everything. There is a number that determines whether a panel building is sound in 30 years, and it appears on no invoice, in no brochure, and in no quote you will ever receive. In 2001, a cluster of structural insulated panel buildings in Juneau, Alaska began failing. Not cosmetically. The oriented strand bored the structural facing. The part actually holding the building up was rotting near the panel seams. Investigators went in, and what they concluded reorganized how this entire industry works. The panels were not defective, and the foam was fine. Air was leaking through poorly sealed seams, and as that air passed through the assembly, the moisture in it condensed. Understand the direction, because it is the reverse of what everyone assumes. This was not rain getting in, this was indoor air getting out. Warm, humid air inside a heated building rises toward the top by stack effect, the same way smoke goes up a chimney. If it finds a gap in a seam, it travels through the assembly on the way out, and somewhere in that journey, it meets a surface cold enough to drop it below dew point. The water leaves the air right there, inside the joint, against the OSB, where nobody can see it. Winter after winter. Until then, caulk and canned spray foam had satisfied most manufacturers. Juno showed that foam in a seam does not reliably stay airtight a cold or damp day when it was applied, a sloppy hour, or panels shifting slightly as the building settled. After that, manufacturers began recommending interior tape in addition to caulk and foam, and taped seams became standard practice. That should have ended it. It did not. And this is the part worth carrying with you. A building professional in Virginia built himself a SIP house in 2008. It tested at a little over 0.6 air changes per hour, nearly passive house tight, one of the best envelope numbers you will find on any home. In 2015, adding on, he found damaged OSB on the roof and the upper walls. His overall air tightness was superb. That was never the problem. His remaining leakage was concentrated at the top of the building, where stack effect drives hardest, and concentrated leakage against a cold assembly is exactly the condition that grows rot. So here is what nobody tells you when they quote an air tightness number. Air tightness is reported as a whole building average. Rot is local. A house leaking a little everywhere may outlast a house leaking almost nowhere except one seam at the ridge, and the second house has the better test result on paper. The tightest envelope you can buy is the one least forgiving of a single bad joint. Here is where the title lands, honestly. $34,200 is real, and it does cost less than a kitchen remodel, less than half of a major mid-range one, and it sits right in the middle of the range most Americans spend renovating a single room. But it buys walls and roof. The finished building costs several times that, and anybody who tells you otherwise is not counting the slab, the crane, the crew, or the entire interior. What that money buys in return is measurable, and it is not small. An envelope testing between 0.6 and 1.7 air changes per hour against a code-built house at 3 to 7. Continuous insulation with essentially no thermal bridge path. Heating and cooling costs down 40 to 60%, paying the premium back in 3 to 7 years. A house that goes weather-tight in weeks rather than months. And a building that is worth exactly what its worst seam is worth, no matter how good the average looks on a report. So here is the one thing to do before you sign anything with any panel builder. It costs nothing, and it takes one sentence. Ask them, will you run a blower door test with a smoke pencil before the drywall goes on, and will you put that in the contract? The timing is the entire point. Before drywall, a bad seam is 20 minutes of work and a roll of tape. After drywall, it is a bad seam behind a finished wall, and you will not meet it again until something goes wrong 7 years later. Their answer also tells you who you are hiring. A crew that has built several of these will say yes before you finish the question because they already do it. A crew that has not will explain why it is not really necessary. Post what yours said in the comments. I read them, and I would like to know how often the answer comes back yes. Next time, the ventilation system a house this tight is legally required to have, what it costs, and why picking the wrong one makes the building worse instead of better.